Hi everyone, today we are talking about something many Amazon sellers care about, how to make a product a bestseller. To be honest, it's getting harder. Let me quick show you what Amazon has become. First, some numbers. In 2025, new sellers dropped to 165,000, 44% less than before. Active sellers fell from 2.4 million to 1.8 million. Even crazier, only 1.6% of topic sellers, about 7,716, made half of all sales. The other 98.4% fought for the right. That's seller numbers. Now the algorithm. In May 2025, Amazon changed its BSR rule. Before it was sell more, rank higher. Now conversion rate is 30% of the whites. They also added return rate, ad performance, and the user stay time. After that, the top 20% of products took over 17% of the traffic. Small sellers cost went up 35% on average. So why does people still fight for the best seller? Because it's available. First, it's a trust single. This product works. Second, it's left conversion by 10 to 25%. Third, it creates a good circle, higher BSR, more traffic, more sales, easier to keep the badge. So on the platform, this connectivity, small sellers can't just rely on gut feeling anymore. We have three goals. First, find the key feature. We will use data to see how price, rating, review count, and discount affect whether a product become a bestseller. Second, compare models. We want to predict yes or no. We will compare a traditional linear model with a generalized linear model to see which work better. Third, give a practical advice based on our results. We will tell sellers what to choose, how to price, and how to manage reviews to help them to find the real way to stand out.
Hello everyone, I'm Ms. Yuan. Next, I will report to you on the data selections for this study and the key finding from the exploratory data analysis. First, regarding the data source, this study uses Amazon bestsellers data from the Kangoo platform covering information on the top 50 books from 2009 to 2019, with a total of 550 records in terms of variable setting. We define the dependence variable Y as its bestsellers. Use the median number of reviews as the cutoff. Books with review counts in the top 50% are assigned a value of 1, otherwise 0. The independence variable X include 4 core features: price, rating, number of reviews, and book category, which are used for subsequent modeling analysis. Next are the key findings from the exploratory data analysis. First, regarding the sample distributions from the bar chart, it can be seen that the number of symbols for bestsellers and non-bestsellers is basically equal, which provides a relative balancing beta foundations for our classification model and effectively avoids biases caused by class imbalances. Second, regarding the price factor from the box plot of price, it can be observed that the price distributions of the two types of books overlapped heavily with no obvious separations trend. This finding preliminarily indicates that the price is not a main factor in determining whether a book becomes a bestseller, and the consumer may be less sensitive to price with selecting bestsellers than we expected. Third, regarding the impact of rating, the rating box plot shows that the overall rating of bestsellers are significantly higher than those of non-bestsellers, with the distributions clear skewed to the right. This indicates that the high rating have a clear positive driving effect on book sales, and the readers' word of mouth is indeed an important force in pushing books onto the bestsellers list. First, in the most crucial finding, there is a strong positive correlation between the number of reviews and the probability of being a bestsellers. From the scatter plot after logo transformation, it is a clear thing that the more review a book has, the higher the probability it become a bestseller. Among of all features, the number of reviews has the greatest predictive influence on the outcome. Therefore, it is chosen as an indicator to determine whether a book is a bestseller. That's all of my part. Thank you.
Hello, I'm Li Ziyi. I will present the linear probability model and show the analysis. First, the model setup. The dependent variable is binary. One means bestseller, zero means non-bestseller. The independent variables are price and user rating. I also use the log of review count to reduce the influence of the original data on the model. The log makes the model become more stable and also more meaningful in practice. Second is descriptive statistics. The average rating is 4.62. The standard deviation is only 0.23. This means most books have good ratings. Next is about the coincidence. The price coincidence is negative 0.004. It means that every $1 increase in price, the probability of becoming a bestseller decreased by approximately 0.4%. The meaning of the rating and the log reviews coefficient can be understood in the same way. This clearly indicates that in the Amazon book market, the accumulation of comments is more decisive than simply the level of scores. Next is the overall fit. The F statistics is 290. The p-value is near zero. The variables are jointly significant. R squared is 0.615. The three variables explain over 60% of the variation. This seems quite good, but this is only half the story. We must check the assumptions. Look at the residuals with Weiser's fitted plot. It shows two diagonal lines. Why? The outcome is only 0 or 1. Residuals are neither 1 minus fitted or 0 minus fitted. These patterns validate OLS assumptions. It is a classic sign of linear model failure for binary data. Now check normality. The histogram is bimodal, not a bell shape. The QQ plot deviates at both tails. The arrows are not normal. Finally, we predict for all books. The minimum predicted probability is negative 1.45, and the maximum is 1.4. 11% of predictions are negative, 5% are over 1. Can a book have a negative 144% chance? No, this makes no sense in business. The linear model treats the outcome as unbounded, but the true outcome is 0 or 1. It foresees the line outside the probability space. So, linear model fails logically. We need logistics regression from GLM. Now, my teammate will present how GLM solves this.
Hi guys, for part 4 in our project, I will walk you through the generalized linear model, specifically focusing on logistic regression. Because our target variable is binary, standard linear model isn't suitable. So we upgrade to logistic regression. You are already familiar with our main predictor, price, ranking, and category from previous parts, so I won't go into detail again. However, I do want to highlight one crucial change. We intentionally excluded the log review count variable, since bestseller status is defined by a review count threshold. Keeping it would cause near complete separation and the coverage problem. The key takeaway here is a logit link function, which mathematically guarantees our predicted probabilities stay within the valid 0 to 1 range. Now let's look at the effect using odds ratios. First, for every $1 increase in price, the odds of becoming a bestseller decrease slightly, but with a high p-value, this is not statistically significant. Second, ranking played a massive role. A 1-point increase in ranking boosted the odds of becoming a bestseller by about 2.7 times, which is highly significant. Lastly, compared to fiction, non-fiction books have significantly lower odds of being classified as bestseller. Moving on to model performance, our GLM achieved an accuracy of 60.7% with moderate precision and recall. But more importantly, if you look at the probability table on the next slide, 100% of our predicted value now fall perfectly between 0 and 1. This directly fits the most serious flow from parse tree, where the linear probability model gave us impossible negative value or value above 100%. And then come to ROC curve. This is further supported by our ROC curve. We achieved an AOC of 0.66675. The curve stays safely way above the 45-degree reference line, indicating that our model has moderate predictive power and performs significantly better than random guessing. To quickly summarize why GLM is superior here, it properly handles binary outcome, ensure valid probabilities, satisfy model assumption, and allow us to use proper classification metric like AUC. Then come to the article part. We implement this in R using a standard GLM function. So in conclusion, the generalized linear model successfully resolved the structural issue of our baseline LM. It resolved the structural it provides a mathematically defensible and logistically sound framework for predicting Amazon bestseller. We are carefully avoiding mathematical limiting.
Well, hello everyone. I'll close with part 5, Insights and Conclusion. There's a quick recap. Part 3's LM gave us a 36.9% effect from reviews, but that was circular logic. Part 4's GLM excluded reviews and gave valid probabilities. So our real question is, what actually drives a bestseller? There's 3 things: rating, price, and category. Here's what we found. First, rating versus price. Rating has an odds ratio of 2.7. The p-value is 0.013. That means a 1-star increase more than doubles your odds of success. Even a half-star improvement, 4.0 to 4.5, boosts odds by 64%. What about price? The p-value is 0.0603. Completely insignificant. A dollar difference changes nothing. So the bottom line is, ignore price, protect your rating. Second, category. Fiction is our baseline. What about nonfiction? Odds ratio of 0.38. That means nonfiction books have 62% lower odds of becoming bestsellers. Same price, same rating. Why? Fiction readers consume faster and leave more reviews. The algorithm rewards that velocity. So the message is, if you are starting out, just pick fiction. Here's some methodological takeaway. LM's high R-squared was misleading. We used reviews to predict a label defined by reviews, circular. GLM fixed this by excluding reviews. This revealed the true drivers, rating and genre. Reviews aren't the cause of success, they're the result. So what should sellers do? There's 3 recommendations. First, keep ratings at or above 4.5 stars. Second, don't waste energy on pricing. It doesn't move the needle. Third, the beginners should start with fiction. It's a path of least resistance. So the final conclusion is, build the right foundation. The algorithm will do the rest. That's all. Thank you.